Hello and welcome to another simple science video. In this video, we are going to look at elastic and inelastic collisions of the chapter forces. Now, in the previous video, I have told you that for conservation, the total momentum in an isolated system is always conserved. And we also know that the total energy in a system is also conserved. Okay? However, one thing is for sure is that the total kinetic energy of a system is not always conserved in collisions. And this is very important in determining whether something is an elastic collision or an inelastic collision. Now, a collision where the total kinetic energy is conserved, where the two more particles that collide together have the same, they have the sum total kinetic energy that remains constant. That is an elastic collision. Whereas a collision where the total kinetic energy is not conserved, then we call that an inelastic collision. So we shall look at a clearer example. As you all may know that Ke, to determine the kinetic energy of any individual particle, you use half mv squared. Now, first of all, let's find out the total Ke on the left side. That is, total Ke is equal to half mv squared of the 2 kilogram ball at half mv squared of the 5 kilogram ball. We shall calculate that, and that should give us a value of a total of 1.1 kilojoules, right? And the total kinetic energy of the particles after the collision is half mv squared of each, and that should give us a total value of only 475 joules. As we can see that the total kinetic energy before collision and after collision is not constant. So therefore, this collision is inelastic. So the total kinetic energy is not conserved. So the initial kinetic and some of the initial kinetic energy can be converted into something like heat energy, sound energy, elastic potential energy, or whatever. Okay? Now we look at the next example, where a ball of 2 kilogram falls onto, collides with the ground, okay, and it bounces up with the same speed. Now let's find the total kinetic energy at start. That's half mv squared of the ball and half mv squared of the wall. Now we're assuming that the wall is a reference point, and therefore the speed is 0, so we only need to consider half mv squared of the ball, and that should give us a value of 100 joules of kinetic energy. And you were to do the same for after the collision, that is half mv squared of the ball and the wall, and that should give you a value of 100 joules. Similarly, so the total kinetic energy stays the same during these collisions, and this therefore means that this collision is an elastic collision. Okay? So, to determine whether a collision is elastic or not, we can use the total kinetic energy method, whether it's conserved or not, like I've just told you, like so. However, there's a much simpler method, and that is to consider relative speeds. That means the speed of one particle relative to another, right? So if the relative speed of approach is equal to the relative speed of separation, then a collision is elastic. Okay? So let's look at this example. In the before it collides, one particle is traveling at 10 meters per second to the right, and one particle is traveling at 20 meters per second to the left. So therefore, it has a relative speed of about minus 10 meters per second to the left, if you were to add the speeds together, the relative speed. And okay, so the relative speed of approach is v1 minus v2, and you should get 10 minus 20. That's a relative speed of minus 10 meters per second to the left. That basically means that if the particle with the lower speed were to stay still, then the particle with a faster speed would be traveling at minus 10 meters per second. Okay? Now let's look at the relative speed of separation after it has collided. And that is 5 minus 15. That should also give you minus 10 meters per second. So if the relative speed of approach is equal to the relative speed of separation, we can say that this collision is elastic. That means the total kinetic energy is conserved, and the relative speeds are conserved too. Okay, now let's look at another example where if the two particles were to hit each other and they were to collide and they were to stick together, and we can find the relative speed of approach, which is the same thing as before. It's minus 10 meters per second. However, when they collide, their relative speeds there is zero, basically, because the two particles are now formed into one and they're traveling at the same speed. They're just stuck together. So the relative speed of approach is not equal to the relative speed of separation, and therefore the collision is inelastic. That means total kinetic energy has been lost. Thank you for watching my video. Hope you have a nice day.